Janet.
Sema.
Nifanye recap ama ni jump right into cardiac glycosides.
Wacha pe recap.
Sawa sawa.
Just give them a recap, it's okay.
Kama hii nilikuwa nne.
Bana.
Imeanza kurekod, sio?
Yeah, ina record.
Okay. Sijui mbona inakata kushare screen. I don't understand. Can you see the slide that I'm sharing?
Yeah.
Okay. So I think we can start. Jumefika 7:22. So utakuwa natumia notes from Kabarak ya Dr. Julia. So I think Stan alikuwa ametupitisha through intro. So I'll just do a recap first. Yeah, what are glycosides? Introduction. So glycosides, they're organic compounds that have like two moieties. We have the glycon and the aglycon. The glycon is the sugar bit of it, and then the aglycon is the non-sugar one, also known as the genin. So glycosides, when they are hydrolyzed, they produce either one or more sugars. So they occur in higher plants in tissues, also from fungal and bacteria cells. They are formed in sorry. They are formed in the liver as part of detoxification of compounds. Kuna mammalian glycosides are also simple compounds, whereas plant glycosides are much more complex. But in this part, we'll be focusing more on the plant side. So glycosides are water soluble and insoluble in organic solvents. So we have the glycon and the aglycon part. So the glycon part, which is the sugar part, is soluble in water and insoluble in organic compounds, and the aglycon is the vice versa. It's water insoluble and soluble in organic solvents. So many important drugs are glycosides, and the pharmacological effects are largely determined by the structure of the aglycon. I think Stan had explained this. If you are not there, you can go to YouTube and you go and watch what he explained. So we have the physiochemical properties of glycosides. They are, of course, colorless, solid, amorphous, non-volatile. They give a positive reaction to the Molish and the Fehling test. If you do not remember this, you can go back to your notes. They are water soluble, as we've said. The glycon and the aglycon part, where some are soluble in water and some are soluble in organic solvents. Most of them have bitter taste, except the populin, glycyrrhizid, which is the licorice, and the stevin, which are used as, I think, sweeteners. Yes. They are odorless except the glycyrrhizin. I can't pronounce it well. In licorice. Yeah. So glycosides are hydrolyzed by using mineral acids and temperatures, or by using enzymes such as emulsin, myrosin, and rhamnase. This is just basically recap. So their roles: detoxification, transport of water insoluble molecules, their source of energy, storing harmful products, regulation of certain functions, and some have beautiful colors, hence they attract pollinators. They're also important as anti and infective activities, and they protect the plants from bacteria, fungi, and viral diseases. So they're classified according to therapeutic effects. So examples, cardiotonics, which we are going to talk about, laxatives, example, the senna, local irritants, green, analgesics, and the likes. They can also be classified according to the glycon part, depending on the type of sugar. For example, if glucose is the glycon part, glucosonides, an example is senoside. If rhamnose is the glycon part, we have rhamnosides, for example, pangolin, digitoxos, it's found in digitoxin. They can also be classified according to the nature of the sugar. The glucosides, the glycogen is glucose. If it's, let's say, mannosides, the glycogen is mannose. They can also be classified according to the linkage. The O glycoside S, oxygen, sulfur, nitrogen, and carbon. And you'll see for the cardiac glycosides, they're mostly the oxygen, the O glycosides. They can also be classified according to the linkage. It's either alpha or beta, or the chemical group of the glycon. They can also be, or they're named according to the plant they are isolated from. Some of them, for example, have salicin, which is from salix, and let's say aloin from aloe species. Yeah. So the general extraction process, you take the plant, you dry it for a few minutes to prevent the hydrolysis process from taking place. You can boil them with organic solvents and boil them with acetone. This is basically a method of isolating the glycosides. So this is what we'll be focusing on, the cardiac glycosides. The group from the word cardiac, meaning they mainly affect the heart. So the cardiac glycosides, you'll see they're largely used in mainly treatment of congestive heart failure. We know congestive heart failure is when the heart doesn't pump the blood really well. So when we'll be talking about the mechanism of action, you'll see how it will help with that. We have this structure here of it's a simple structure of how the cardiac glycosides look. Can you see my cursor?
Yeah.
So it has three parts. It has the sugar moiety, the steroid. I will name this A, B, like the heterocyclic structure. Where has the cursor disappeared? So this will be A, B, C, D, our rings, and then it has the lactone ring. And on the third carbon, you'll see that it will link to the sugar moiety. On the 17th, it will link to the lactone ring. And then the A and B rings are linked together. These rings are, first of all, they are saturated, so they're linked together via the cis. You remember the cis and the trans? So A and B are linked via the cis. What is it? They're bonded via the cis. What is it called? Yeah, they're just bonded by the cis, and then also C and D.
Configuration.
Sorry? Okay, and then
I
we'll
think
see
it's a
that.
configuration. Oh,
Yeah, the
sorry.
configuration. Yeah. And then we'll see that the lactone ring, there are two types. There's the 5-membered ring and the 6-membered ring. So the 5-membered ring is for the cadenolides, we'll see them. And then for the 6-membered ring, it will form the bufadienolides, yeah. So the mechanism of action. Okay, you remember the CHF we were talking about. So normally the sodium potassium ATPase it pumps out sodium and pumps in potassium, which affects the sodium calcium exchanger, which pumps the sodium calcium exchanger, which pumps in the sodium and out the calcium. So the cardiac glycosides act by inhibiting the sodium potassium ATPase, which will in turn inhibit the sodium calcium exchanger. So if you inhibit this, you'll cause an increase in intracellular sodium and calcium. And you know, when calcium increases, it will increase the contraction forces, thus causing the heart muscles to contract more, thus acting as a cardiotonic, which is used in treatment of congestive heart failure. So the distribution in nature, we have four major families in which the cardiac glycosides are from. We have forgive my pronunciation, Scrophulariaceae, Liliaceae. Okay, for the first one, we have the digitalis, the most common one, digitalis pipera, also known as the foxglove, and the digitalis lantana, which is the white flower, which is also known as just a minute, let me get the name. Digitalis, it's known as the Grecian foxglove. We have the Liliaceae, we have the Apocyanaceae family, and the Ranunculaceae, which are the main families in which the cardiac glycosides are from. So remember we were talking about the bufadienolides, which are the 6-membered ring lactones. I believe there's a structure here. All these are examples of the pictures. I believe you're familiar with this purple one. It's the digitalis. Yeah.
Before you move on, can you please repeat the mechanism of action?
Okay. So normally we have the sodium, potassium. Let me go back. We have the sodium, potassium ATPase. This works by normally it works by pumping out the sodium and pumping the potassium inside the cell. And once it does this, it causes that ionic imbalance, which is stabilized by the sodium calcium exchanger, which pumps the sodium inside the cell and calcium outside the cell. But now the cardiac glycosides, they work by inhibiting the sodium potassium ATPase. So when you inhibit that, you inhibit the sodium from moving out and the potassium from moving in, and also you'll in turn affect the sodium calcium exchanger, whereby in the cell the sodium and the calcium will increase and the potassium outside the cell will increase. So when the sodium and the calcium inside the cell increases, it causes sodium is calcium is associated with the contractility. So when that increases, it causes an increase in the contraction forces of the cardiac cells. That's the cardiotonic effect. Are we good, Jess?
Yeah, tuko poa sasa. Thank you.
Welcome. So these are plants that are associated with the cardiac glycosides. Or we also have toads. We can see this examples of animal sources. You have the toads, snakes, and fireflies. Usishangae mkiona toads hapa. So this purple one is the digitalis pupera. So this is now what I was talking about, the two groups of the aglycons. So the structure is the same, the only different part is where the lactone is. Now we have the cadenolide, which is the cadenolide is the 5-membered ring, and the bufadienolide, which is the 6-membered ring. So here is an example. The only difference is the lactone, which binds to the beta, to the 17th carbon. Hope you've seen the difference. So I remember Dr. Nelly used to ask these questions, like the linkages. So I had explained about the ABC. The configuration is usually cis because the steroid ring is saturated, and then on the 3rd carbon, it's bonded to it's beta bonded to the glycone part, and on the 14th carbon, we have an OH, which is beta bonded as well. And on the 17th carbon is the one that is this one here, linking to the lactone group. So this is the structures of the cadenolides and the bufadienolides. So I hope you should be, okay, if you're not paying attention, now pay attention here. So all cardiac glycosides are characterized by the following structures: the presence of the beta OH at position C3. That's what I had mentioned. So when you increase the number of sugars, you can increase the water solubility. We have the presence of the unsaturated 5 or 6-membered lactone ring at position 17, as you've seen in the diagram above, which is also a beta configuration, and also there's OH at carbon 5, carbon 11, carbon 16, and carbon 14, which is not included here, as you can see from this structure. I hope si working busy sana. So some of the examples of the cardiac aglycons, we have the aglycons are the non-sugar part. So we have the digoxin, digitoxin, digitoxin. We also just some of the common aglycons. So this is just what I've explained: the sugar portion, the non-sugar portion, and the R class, the lactone. Basically, this is a repeat of what I've said, but you can still go through them. They have the alpha, beta unsaturated 5-membered lactone ring in carbon number 17, methyl group at C10. This is just basically a repeat of the explanation of the structure. So here we have digitalis and the staphylococcus glycoside. So the only difference is in the R group here, where for the digitalis it has a methyl group, and for the staphylococcus it has this group here. So cardiac agents that have double unsaturated 6-membered lactone rings at C17, they are bufadienolides. I had already explained this. Mm, so this is a repeat where at position 3, they contain the monosaccharide molecules are the sugar part of the structure. With the exception of D glucose and L rhamnose, other sugars can be found, which are uncommon. Deoxy sugars. Okay, a deoxy sugar is a sugar whereby the hydroxyl group is replaced with the hydrogen atom. So the examples are the deoxy, digitaxose, this one's the D sugars. So here are the structures, how the sugars looks like. And I think from here, Janet can take you through. Janet, are you there?
Oh, hi, sorry. So I hope my background is not too loud.
So,
Okay. So we go to the SAR, translating totals. These cardiac glycosides have a steroidonuclease, and they also have a lactone ring as well as a sugar part. So opening of the lactone ring, then alkali will result in the loss of the activity. So like in some of the tests you're using, we'll be using alkali. If it's too strong, it will give you a negative result. Saturation of the lactone ring also reduces.
sorry.
Okay.
Taniambia
Saturation of the
when to
lactone
move.
ring. So it will reduce the potency tenfold or even destroy the cardiac activity. Tumeona hizo the 4-membered and the 6-membered, the 5-member and the 6-membered ring, they both have are both unsaturated. One is monosaturated, the other one is disaturated. And then we have the cis junction. Tuliambiwa A, B, and C. A, B are in cis configuration. C and D also in cis, and then there's the other, but A, B, and C, D, they're in trans configuration. That is also important for the cardiac activity. The change of the location of the hydroxide group modify the cardiac activity or even eliminate it completely. Next slide. Sugar attachment to the steroid part modifies pharmacokinetic as well as pharmacodynamic activities. This is because the sugar part affects the solubility of the glycosides. The longer the sugar chain, the more soluble it becomes. So solubility will end up affecting the pharmacokinetic and pharmacodynamic. Yeah, and that's it. Next slide, Mona. Free glycons are absorbed faster than than the ones bounded. Sorry, listening.
Sorry.
It's okay. Yeah. So those 2 points are related. The free glycons are absorbed faster than glycosides, than, and they are also easily metabolized. So it is said, once you change the solubility, if the sugar part is more soluble, it may end up being the glucose, so it will lead to it being easily metabolized. So it will act fast, but it will also have this last shorter. The sugar moiety is significant for digitalis, but it hasn't shown any activity. Next slide.
Oh, yeah.
Yeah, the glycosides, they are soluble in water and alcohol. The longer the increase in number of sugar will increase the water solubility. Glycons are soluble in chloroform and ethyl acetates. Next slide. So these cardiac glycosides, when you add them to acid, they will end up splitting. The sugars will be split from the aglycone. For enzymatic activities, we see that it will end up splitting the sugars from the last sugar. It will end up shortening the sugar chains, the smallest. The temperatures will also lead to hydration of these glycosides to give an inactive and hydroform, which I don't know if I've gone to it, but in extraction of digitalis, one of the things you have to be careful of is the temperature and also its hydrolysis. Next slide. Okay, we can go into is my background too loud?
Ambia Patrick anyamaze, hata si mfanyi.
I never.
I move to the next slide.
Thank you so much.
Okay, sorry for that. Nimemnyamazisha sasa. Right, so we can go and see some of the side effects of cardiac glycosides poisoning. So consuming parts of next slide.
Okay.
Next slide. You can end up consuming easy cardiac glycosides from plants or teas brewed from this plant. Also for smoking, from the smoke of burnt oleanders. There's the aphrodisiac reputation of the content bufotoxin, particularly pitafuta, suicide attempt or inappropriate self-administration of for the therapeutic purpose or their overdose. So these are some of the causes that may lead to poisoning. The mechanism of action is we learned these cardiac glycosides work by inhibiting the sodium potassium ATPase. So this will lead to excessive calcium, leading to enhanced cardiac contractions. They also have this vagotonic effect, which will lead to bradycardia and heart block. Inhibition of sodium potassium ATPase in the skeletal muscles results in increased extracellular potassium and contributes to hyperkalemia. And hyperkalemia will also contribute more to the bradycardia and arrhythmias. CGs primarily affect the cardiovascular, neurologic, and gastrointestinal systems because of that whole electrolyte imbalances. For children, what side effects will you incur when they have taken too much of it? Tetanus, abdominal pain, the common one, DNV, lethargy, more flash, and I think that is circular flashes, redness in the face, maybe. Dilated pupils, drooling, sweating, shaking, acid pallor. For adults, you'll see them having, next slide, they'll have the bradycardia, heart block. I don't know why the children are experiencing it. Premature ventricular contractions. A common but unusual complaint is the xanthopsia, which is the yellow vision, and others include the weakness, dizziness, and drowsiness. Next. Management. How do you manage in case somebody has gotten this poisoning? Activated charcoal evolutes to prevent further absorption. So that will mean you'll have to administer it at least within 30 minutes, I think. Then there's the hemodynamics. Yeah, that is easy to do ingestion, at least 30 minutes after ingestion. Hemodynamic support, the fluid replacement, electrolyte collection. Antiemetic, where vomiting is dominant, you'll see further that some of these CGs, they have emetic activities with large doses. Alaska atropine for severe bradycardia, phenytoin for arrhythmia. So basically, it's just managing the symptoms that will occur. Next. For the field glycoside. So these ones are available in there's a red and then there's a white squill. The white squill is mainly used for is expectorant, and as I said, in large doses, it has emetic activity. Next slide. Hii ni dawa zenye gas anazanga, sijui kama kunayo. Remember, will be used to add flavor to it. Next. Okay. So this red krill is used as a rat poison because it also has selective toxicity because these rats do not have the emetic vomiting reflex. So as it has that affected in your mingi, so they'll end up dying. But for other like the domestic animals and stuff, they'll end up vomiting it before they reach the middle dose. So that's a good thing. Next slide. So we go to the test for glycoside. So the general test for series, you have the Liebman's test, um, whereby the glycoside in acetic anhydride plus, and then you add a few drops of concentrated sulfuric acid, it will give a green color. I think we've changed from violet to green, but it will then result to be a green color. For the deoxy sugars, we use the Miscellanous test. I think we talked about this for carbohydrates. Glycosides in acetic anhydride containing traces of iron trichloride. When you add concentration of sulfuric acid on the wall of the tube of the test tube, the acetic acid layer will get bluish color for the digitalis and red color for the squares. For the next slide, for the 5-membered lactone, that is the what do you call it? What is the word? Cadenolides. The cadenolides are the 5-membered lactone. These done by a group of colored reagents that are alkaline solutions of aromatic compounds. So in this case, you'll end up using the Kid's reagent, which is mainly D5-dinitrobenzoic acid, Raymond's reagent, which will use the methyldinitrobenzene, the Burgess reagent, and the legal test. So all these will give a positive test if it's a cadenolide. You see there are two types of genes, your cadenolide and the phosphadienolide. Remember those two, cadenolide and phosphadienolide, or 5-membered and 6-membered lactones. Next. Okay, so they'll react with active methylene to give a positive test. So this for the so is it kid or kid? I don't know how you pronounce that test. But it will give a pink, purple, violet color in presence of a cadenolide. Note, if it in presence of a 6-membered ring, it will give a negative result. So for this one, it should give, for kids test, you give a pink color. And then for Raymond's test, by using the methyldinitrobenzene reagent, it will give an yellow, it will give a purple or violet color. Or purple color, I know the book you use. And for budget, the cardinal will give a yellow to orange color with the alkaline picrit solution. And use acetic acid. For the legal test, a small amount will dissolve in pyridine into 2 ml of nitroxide, and then you add a small amount of sodium hydroxide to give a red color, which will give you a positive test for the cadenolide. Next slide. Chemical test for this name. That one. We have the sulfuric acid, which gives a pink color with somebody pronounce that word for me because me don't know how to pronounce it. No, the plant.
Overbuying. Overbuying.
Actually, overbuying.
Oh, you're buying. It's
okay.
you're buying.
Sawa.
Like,
You're buying.
That's wrong. It's not pronounced that way.
Okay. That's a mess up. So, you're buying. You're buying will give a pink color that return to green fluorescence. That is interesting. And there's also one test I saw in Nelly's notes, which was called the antimony trichloride test. That is for both the 5-membered and the 6-membered ring, and it gives a blue or violet color that you will use the UV to differentiate whether it's a cardenolide or it's a bufadienolide. Hi. Applications of these pharmaceutical products. It's used to treat congestive cardiac failure, antiarrhythmic agents, prevent and treatment of cancer, such as that extract from Anzizel, and then we have for neurodegenerative disorders. Also, they do have an effect on skeletal, neurological, and cardiovascular muscle. Next slide. Next one. Okay, so we can use these questions as a recap. We didn't even have a question before you continue. We do a recap. I think.
Pardon?
No,
Pardon?
I said we can use these questions to do a recap because they do cover the areas we've covered right now.
Okay.
Yeah. And we'll start out by defining what's a cardiac glycoside.
I think what's a cardiac glycoside?
Yeah, simuliza, define it.
Unauliza watu. Sawa, wacha ni mute.
Wewe ndo unaanza.
Wewe ndo unaanza.
Guys,
I don't know about leukemia.
If you don't know, can you just keep quiet? So to glycosides here. Anybody, give it a try. Use your own word. It's in the name. These glycosides that have an effect on the cardiac contractility, an effect on the cardiac muscle or on the excitability and contractility of the heart, of the CVS. Discuss the distribution of stages in nature. Anybody? Okay. Hey, this is a good class. I love it. You're very active. So,
very.
They can be found in the leaves, the roots, and some of the families. Let's mention one.
Liliaceae, Apocyanaceae, Scrofulariaceae, those ones.
Yeah. Microbiota, Miliona, something leguminous, something like that. Also something like that. Okay. Explain the pharmacological activity of CJs. Jasmila, tell us that one.
Mfuru.
Hata hapa.
I explain?
The pharmacological activity of cardiac glycoside.
They inhibit the sodium-potassium pump, so there's no pumping out of sodium and pumping in of potassium in the heart.
Continue.
Also, the other part. Yeah.
Okay, yeah, that's a good attempt. Like you're right.
Umesema tu half.
Yeah.
Ina increase pia the calcium.
Patrick akona answer. Hebu atueleze.
Oh, okay. Patricia.
ameenda kwa manzi yake achana naye. So, Mfuru alikuwa anasema ina inhibit the sodium potassium ATPase. So that will lead to letting maliza. Hiyo depends on
ukiinhibit sodium potassium ATPase in turn una inhibit the sodium calcium exchanger. So there's an increase in intracellular calcium and sodium and increase in extracellular potassium. So the increase in the intracellular calcium in increase contractility of the muscles. So in turn, the muscles in a contract strong, way more kwa nguvu.
Stronger contraction.
Yes. Perfect.
I am not wrong.
Haya, toxicities. The common nausea, vomiting, diarrhea. Janet, endelea.
Nausea, vomiting. Number 1 in your list. Nausea, vomiting.
Number 2.
Bradycardia.
Yeah, bradycardia, heart blockage, hyperkalemia, ashy coloring,
Dysrhythmias,
lethargy.
anemia.
Alafu distinguish the types of cardiac genins. Hizi ni the aglycon part. Yeah, the cardiac glycosides.
Hapa ndio cadenoline na ile butadienol yenye iko na double bond na moja single ama ni gani?
a difference in the
Yenye iko
number
na
of
monosaturated. Oh, it's not that.
no, the difference is the members. No, you're right.
Uh-huh.
The difference is the members. The rings, the number of members in the ring.
Now here is
Oh,
the cardiac genins. I thought ni the aglycons, like the digoxin.
Hapo ni stereochemistry. Alafu kuna zile za indefinite structure kama hiyo Uber gene.
Ati kama?
Kuna za stereochemistry, like difference chemistry.
Oh no, mko sawa, mko tu sawa.
Difference in structure. Na alafu kuna zingine miscellaneous. Kama ingine inaitwa Somali. Sijui ya Wasomali ama ni.
Yeah. So next, list the characteristic features of cardiotonic activities. Guys, shine.
I think characteristic for cardiotonic activity. Characteristic features for cardiotonic activity.
Yeah.
Mimi naweza sema hiyo I think it's the pharmacological action, but naona that was asked under number 5. So I don't know. I don't know what will be the answer to this. Maybe
Can it be the excitability and
Number 5.
can it be the excitability and can it be the excitability and contractility of the muscles?
Yeah, I was also thinking the same.
Ah, oh, okay, yeah. Oh, that's not under number 3. Oh, sorry, under number 3, I meant number 3. It's not pharmacology.
It is, but what are the characteristics of that pharmacological action?
I get you now. I get you, Holly.
Okay, haya. Discuss the tests. Hizi Janet amezisema tu sai. Legal.
Acha azirudie.
Okay, Damando Kid. Those tests.
For the
Raymond budget ziko tu hapo. Kama ulikuwa unapay attention unaweza jibu hizi zote.
Maybe Viola tusaidie manze. She's an expert in pharmacognosy. I mean,
The floor is yours.
I think ni angetufunza hata. I'm surprised she's here. Viola, tusaidie hiyo swali. Ameniambia ako busy. Haya, wacha tupe tu Janet.
Janet,
Hi.
take over.
Tester, these ones mainly we covered for cardinolines. Na tulisema kuna ya key reagents, which is the nitrobenzoic acid, and then it changes color to pink, purple, or violet. One of the colors, depends on if you're colorblind. For Raymond, we have metadinitrobenzene. The color is orange. For budget, it uses citric acid, the alkaline citric, and gives orange color. Legal test, inatumia sodium nitrochloride to give a deep red color. Nashika hizo. I think those are enough.
Yeah. I guess that's it from us. For cardiac glycosides. Any questions?
Nice.
Naona
Hello.
hii number 5. Examples ya naona wanasema the non-sugar moiety is also called the genin.
The genin,
so ni hizo,
yeah.
So ni hizo, so uta classify hizo madigoxins is according to the classes. Like,
okay.
Where is it? This one. Mona. Hizo ndo glycons.
Okay. So I think Linda, let's say signing age 15. Okay. Can we say age 20? We start on isoprenoids. Age 20 is fine. 10-minute break.
Amesema sawa.
Okay. Yes, but for cardiac glycoside, most important thing just to know digoxin and the source. Hiyo is a common question. Hata kwa kumatch, that one you will definitely find it. The source digitalis and digoxin. So zingine the SAR don't kill yourself.
Ni stop kurekod ama iendelee?
Unaweza stop, unaweza pause, upause, usistop.
Okay.
They will just continuous, yeah.
Pause.
Hi guys, can we continue?
Yeah, Linda, niwe tunasikia.
Okay, so huge disclaimer. I'm not so good with pronunciations, so you'll bear with me. There are so many difficult words for me here to pronounce, but yeah, you'll just have to bear with me. So I'll be taking you through, guys, miscellaneous isoprenoids, which are also called terpenoids. So I had a few questions here just before we begin. So how do we define isoprenoids? So they are any class of organic compounds composed of 2 or more units of hydrocarbons with each unit consisting of 5 carbon atoms arranged in a specific manner. Identify the sources, physical and chemical properties. So for this group, the sources are obviously plants, animals, insects, bacteria, and fungi. Basically any living thing. So in plants, they usually occur as essential oils. This generally means that they are volatile, which are found now in gummy exudates. They occur as secondary metabolites, so they have an effect in growth in plants, and they contribute most of the time. They are red, yellow, or orange pigments. In animals, it comprises of various oily or waxy substances, such as fish liver, oils, wool wax, and the yellow pigments in egg yolk, butterfat, feathers, and fish scales. So with that, I think maybe you have an idea of what isoprenoids are. They are found in egg yolk. Most people have seen that, butterfat, and now fish scales. So the introduction bit. So isoprenoid compounds are compounds that contain isoprene unit as fundamental building blocks. So if there's a question like, what are the building blocks for isoprenoids? You'll just know that they're isoprene units, hence the name. So these compounds exist, they are actually secondary metabolites. So they allow for the biosynthesis of unrelated compounds. Isoprenoid synthetic route is called the mevalonic acid pathway. and this is very important, it can be asked, mevalonic acid pathway. And there are two forms, the R and S, but the R form of mevalonic acid is the one that gives terpenoids. The S seems to be metabolically inactive. The major regulatory enzyme in the isoprenoid pathway is the hydroxymethyl butyryl, that one, CoA reductase. So these isoprenoids, they differ in their functional groups. So, for example, terpenes may occur as alcohols, ethers, or ketones. When the aldehydes are a functional group, they may be aliphatic in origin, aromatic, steroidal, or steroidal. So again, I said they are secondary metabolites, and they are responsible for the characteristic odors and color of plants. So they are responsible for the odors because they are volatile. So that's why they give out odor. So they give distinct plant, culinary, medicinal, or poisonous characteristics. It is suggested that they are biosynthesized to aid the plant survival. So they are used to scare off, like plants will use it as a survival mechanism to scare off like predators. So they have the following groups, and these groups goes down by the number of carbon units. So monoterpenes are the smallest group. And then now as we go down, the number of carbon atoms increase. So this is the category. So we have the monoterpenes. I'm going to tackle that today, but the rest will be tackled tomorrow. The rest are not it's not a lot of content. The monoterpenes was the heavy bit, so I'm going to cover that today. So the monoterpenes are a class of terpenes that consist of 2 isoprene units and have the molecular formula of C10H16. So sometimes they can have an oxygen as a functional group. And these monoterpenes are mostly volatile, which accounts for their fragrances. So as you go down the group, as they become bigger in molecular weight, they become less volatile. So the first group for monoterpenes that I'm going to tackle are the iridoids. Iridoids. Yeah, I think it's iridoids. So for this, they are cyclopentane pyran monoterpenoid. So it's very important to know where they are derived. So as I go through the examples, it is important to know where they are derived from, their uses, and which part of the plant they are extracted from. So for this, they are derived from irido. I can't pronounce that, but that. Again, they are secondary metabolites present in various plants. So there's a genus of ants which produce these compounds as defensive secretions. Most occur as glycosides, some occur as free and as base compounds. The next group is the gentian. So this group is known as gentian root in the BP, and it consists of, now this is the important part, it consists of dried fermented rhizomes and roots of the yellow gentian. The yellow color of the fermented gentian root is due to xanthons and includes genticin. So the uses, most of these monoterpenes are beta tonic. So you'll find they are mostly used to treat GIT conditions. And since they are beta tonics, beta tonic basically means something that stimulates appetite. So in case you ever forget, just know beta tonic stimulates appetite. So they are always used as appetite stimulants. So in the traditional medicine, it was used to treat gastrointestinal conditions as anti-inflammatory and wound healing agents. Also reported to have choleratic, antioxidative, hepatoprotective, and antifungal activities. So for this group, those are the users. We go to the next group, which is called the sanctuary. Yeah. So the BP also just knows it as sanctuary. The family is the Gentianaceae. Yes, that's the family. So this is very important. This is a very important point, the family. So it is found in dried, flowering aerial parts of, yes, those the below families that you're seeing there. The drug has a very bitter taste, and due to small amounts of sesquiterpernes glycosides. You remember from the first group where we talked about iridoid, we said they're bitter tonics, and that means they have bitter tastes. So these iridoids are contained in centauri. So that makes them to have a bitter taste. So from this, you can already guess one use. It will be used to treat GIT conditions, and it will be used as an appetite stimulant. So compounds include the ones that are listed there, just because I cannot pronounce them, but you can read them. They use, it is said to act on the liver and the kidneys to purify the blood and for jaundice. Also traditionally is used to treat fever, hence the name fever wort. It has a bitter taste, I said that, so it will definitely stimulate appetite and increase the secretions of bile and gastric juice. The next example of the monoterpenes is the bog bean leaf. So it's still known as the bog bean leaf in the BP. The family is very important to note, and it's the one that is on your slide there. I'm sorry, I cannot pronounce that. So the uses of this, again, it is beta. It's a beta tonic. So it is used for its beta and diuretic properties for the treatment of various rheumatic conditions. So this will be used as a beta tonic, and also it's very important to know that it's the only group that is used for rheumatic conditions. That's the bog bean leaf. If there is one takeaway message, is that it's used to treat rheumatic conditions. The next one I'll tackle is the plantain. So there are 3 common European plantains that are listed there. Please read and bear with me. So they are the common weeds of lawns, and they are found there as common weeds of lawns and cultivated grounds. So they are obtained from dried leaves, and they are obtained at the time when the leaves during time of flowering. So it's important to note that these ones are obtained from dried leaves, and they are collected during flowering time. They also, the constituents include the iridoid. If you ever see this, you just know it's a beta tonic. So again, we will definitely know that it will be used for GIT. So the users here say that it depends on the stated expectorant. Oh, sorry, it is, traditionally use of plantain depend on its stated expectorant, diuretic, and anti-hemorrhagic properties. So for this art, our take-home message can be that it is used as an anti-hemorrhagic, and also as a diuretic, aside from it being a beta tonic. The next one is the valerian root. The family is there. Bear with me again. The plant species also there on the slide. So for this, we focus on the rhizome, stolon, and roots, and they are normally collected and dried at a temperature below 40 degrees Celsius. It is also obtained from wild and cultivated plants. Whatever that its constituents again include of this iridoid esters, and also alkaloids are there. So here, what I saw that was very important is to just know that it's found in the rhizomes, stolons, and the roots. So there are other drugs that are related to valerian roots, and they include these specific ones, the three here: Indian valerian, the next one, and the other one. They are those three. They are very important to know. They are the drugs related to the valerian root. So for the action and uses of valerian root, it is used to relieve flatulence. It is used as an antispasmodic and for other nervous disorders. It's mostly used as an antispasmodic, especially when it is hysterical. So it's very strong for that use. It is used in treatment of sleeplessness and to reduce anxiety. It is often prescribed with bromides and other sedatives. Most of them are used in the perfume industry. The next is the devil's claw. So it is called the devil's claw just because of the way the fruit looks like. So there's another slide that I'll send in the group that shows images of this particular plants that we're talking about. So it is called the devil's claw because the structure of the fruit looks like a devil's claw. So it is also known as the devil's claw in the BP, and it consists of, this is important, cut and dried tuberous secondary roots of that plant. So its constituents are the roots, of course, and again, you will see iridiod glycosides there. They also, flavonoids also are there, phenolic acids are there, etc, etc. Actions and uses. So it is, sorry, I had mentioned something for I thought it was, yeah, it's also used for rheumatic disease, and also it's used as an anti-inflammatory agent and an analgesic. And yeah, now that brings me to the end of my topic. So I wanted to make this short so that, because this topic is extremely wide, so I just put in the points that I saw important. So for today, we've only covered the monoterpenes, but tomorrow Seraphine will take us through the rest. And if you have any questions, maybe you can write them down and I will assist Seraphine in answering them on Monday. Gaius, to you.
Thank you so much, Linda. Thank you so much. That was so nice. You're good in teaching. Umetupeleka vizuri. Maybe we can get the view from people. Because Seraphine, kama ako prepared with the stuff.
Yeah.
If people are willing, we take a break even if it's until 8:55. Then we come back and do maybe just the Sesquiterpenes if people are willing. So najua mlisema kwa mute hamtani. So unaweza tuma ka emoji ka thumbs up if you're okay. We take a 15-minute break. We come back and do Sesquiterpenes. Sesquiterpenes, sorry.
Unaweza pause, no?
Yeah.
Yeah.
Though I'm using my phone, I need someone to help me share the notes.
Sija download mimi.
Download, okay. Linda, share the notes. At least when a Joe may download or someone else who has downloaded the notes from slide, I think 55.
Okay.
Okay, yeah, we can now continue from here. Sesquiterpenes, Linda has already covered monoterpenes. Monoterpenes, we said they have two, that's what was that core structure called? The isoprene units. Yeah, so monoterpenes have two isoprene units. Sesquiterpenes now have three of those. Three of those, like two monoterpenes. Yeah, anyway, yeah. Yeah, sesquiterpenes, yeah. So we can start from here. Their structure can be linear, monocyclic, or bicyclic. And most of them are secondary, they constitute a large group of secondary metabolites, which are those stress compounds that are produced either when the plant is maybe injured or has a disease, the ones we were discussing, like kina gums and such. Yeah, and then they are found to be major constituents in volatile oils and resins, like Linda said. However, she also mentioned that as they increase in size, like their volatility will decrease. So basically, that means monoterpenes will be more volatile than sesquiterpenes and so on. Next. Yeah. So now, yeah, sesquiterpenes, it's just a very large group with the Compositae family, but they can be found in other families. What else is important here? So generally, they'll have anti-tumor, anti-leukemic, cytotoxic, and antimicrobial activities. And then, yeah, so generally, and then the lactone can cause skin allergies. And then they also, since they have either a very bad taste or such, then they'll have a feeding deterrent for insects. So they also act as anti-feedants to protect the plants. So those are examples of the sesquiterpene lactones. The 4 examples. Can have a look at them, then we move to the next one. So they're classified according to their carboxylic skeletons, and that's now from the structures you've seen on the previous slides. Then now we get the 4 of those classes in the previous, that structure in the previous one. So an example of a sesquiterpene is the Santonica flower, feverview, chicory, and arnica flowers. So those are the examples. And then we'll also look at Artemisia. Yeah, those are the examples that we will look at. So basically we look at the common names. Maybe we can look at the scientific name, the part of the plant that produces that compound, and their function. Just those three things for each of them, then we are good to go. Okay, now we can start the individual ones. So we'll start with arnica flowers. So this one is derived from either whole or partly broken dried flower heads. So the dried flower heads, what are they called? The flower heads, they are dried and crushed to give now the active part of the arnica flower. These are now some of the constituents in the plants. My peeps, you can go through that, but personally, I don't think that is very important, but you can also go through it at your own time. But the principal active, the principal active constituents are now what will give rise to their functions: the anti-rheumatic, anti-arthritic, and anti-hyperlipidemic, and also respiratory analeptic properties. Yeah. So for the respiratory analeptic, they basically just stimulate the CNS to, they stimulate respiratory muscles to do their thing, but not directly by interacting with the muscles, but through the CNS. Like, they have that respiratory analeptic property. Sijui kama mmeelewa chenye nimesema aki hapo. But yeah, let's move on, Linda.
Iko sawa.
Iko sawa. Okay, then another plant, another also thing associated with the arnica flower is the arnica. Now another species is the arnica montana. Also, you can use flowers, but the rhizome is what will constitute most of the arnica. Yeah, the rhizome is what will constitute most of the active, unlike the other one where the flower gives most of it. Yeah. Next. Yeah, so it has astringent properties, and it's used either you can make a tincture or an infusion from either the dried flower heads or the rhizome, and then it can be used now to treat sprains and bruises, but it should not be used on broken skin. And since we said some of this, they have a tendency to develop allergies. So in the event that someone gets a reaction or they develop dermatitis, then you discontinue it. So that's for arnica. Then now feverview. So feverview, scientific names, my guys. Tanacetum parthenium, okay. Sawa. Moving on. Now, continue, move next. Yeah, so next, or yeah, so just like it also, they have, like, each of these plants, as much as it has the active, there are also so many other things, like it will have tannins, flavonoids, and so many other things that, so, but now, like for this one, the feverview, it has that's A and the B, whatever those names I had, those ones. A group, which are the guanylide group and magnoliolide. Those two are the main components which gives feverview. It's what are they called? They are what makes it like its functions, it's due to those groups, those specific ones. Let's get to the next, yeah. Yeah, so it's used fever view. So basically fever, at least even if you forget all the other functions, we'll remember fever view is used to treat fever, arthritis, migraine, and also some menstrual problems. And then we also have chicory, which is from Chicorium intybus. So for this one, you get dried roots. Dried roots are what is used to make now the drug, or which have a high concentration of the active. Let's move on, Linda. So decoction is done on the roots. Then the product is used either due to its diuretic activity or to treat liver ailments. It can also be used as a tonic. And like Linda said, when you see tonics, GIT problems and such, so it can be used as laxatives also. But then also you can, yes, you can do decoction and use the product, or you can just roast the roots and then use it as a substitute for coffee, which would also give the similar benefits. And then we have fish berries. Yeah, fish berries from Anamita cocculus. The seeds of the plant are very bitter, and Linda said, you see bitter, then you can always come up with one of the uses. And then but also something interesting about the fish berries is that when they are like compounded or something, then they can be used intravenously in poisoning by barbiturates. Then we have Satonica flower. Satonica flower is from the unexpanded flower heads of Artemisia sina. So for Sesquiterpernes, yeah, Artemisia sina, Sonica flowers, then of course we'll now do the other kawaida Artemisia we are used to. So for Satonica flower, it's used for antihelminthic. It has antihelminthic properties, and it's specifically used on roundworms and to some extent threadworms. So antihelminthic for Satonica flower, which is also Artemisia sina. Then now artemisinin, which now the kawaida one we are used to. This one, of course, we all know it's used for managing malaria, the Plasmodium falciparum one, particularly cerebral malaria. Yeah. Yeah, then Gispol. Gispol has hemigispol and related aldehydes. For Gispol, it's the immature flower buds or the seed kernels from the cotton plant, and it's used as an insecticidal, and it also functions as a male anti-fertility agent. I don't know how that is going so far, the male anti-fertility agent, but ni sawa tu. Yeah, then go back to the previous slides, Linda. Yeah, so I think that's the end for sesquiterpenes. So basically sesquiterpenes, we have talked about a few ones. Anica flower. For anica flower, we said we use the dried flowers, and anica flower has anti-arthritic properties, anti-hyperlipidemic, and also can be used as a respiratory analeptic. We talked about feverview. We said feverview, fever, arthritis, migraines, and menstrual problems. We talked about fish berries. We said for fish berries, it's used for, the most unique thing was it can be used intravenously in poisoning by barbiturates. Then we've talked about Santonica flower, which is from Artemisia sina. We use the unopened flower heads. It has antihelminthic properties, more specifically roundworms. Then we talked about Artemisia, the kawaida one, Artemisia annua, which is now for malaria. The Plasmodium falciparum. Then we talked about Gispol, which we use immature flower buds and seed kernels. It has insecticidal activity, and it also can function as a male anti-fertility agent. So I think basically that's it for sesquiterpenes, my people. Yeah, kama kuna swali, we can do it now, or we can do it on a Monday when we finish the isoterpenoids. Isoprenoids.
No questions from my end. Maybe Sonia kuna swali. I know she's very passionate about gossipol and it being used as a male anti-fertility agent. I don't know if she has any input on the same.
Swali yangu ni nani hajalipia dina? That's my question. Mimi na gossipol hatujuani. Mimi na gossipol.
Okay.
Tevo sasa ndio anahitaji gossipol maybe, but
then you can stop the recording.
Oh, okay. Nikistop inaenda kwa cloud just now.
Ukistop inaenda kwa cloud.